right, Michael, and whoever's watching this, this is, I don't even know what section we're on. 1-4. We're on example 5 of 1-4. I think I told you yesterday to do like up through 68, but I think 68 is exactly like example 4. So if you're confused on 68, example 5 is 68. Okay, so here we go. Example 5. Write an equation of the line. Okay, let's talk about equation of a line. How do we write the equation of a line?
Good question. B.
Y equals mx plus b. Y equals mx plus b. Okay, that passes through the point. 2 comma negative 3. That's what they give me. And they say the slope is negative 4.
So let's plug in Y
So,
and X.
we know that m
Negative
is
3
negative 4.
equals negative 4 times 2.
And to figure out b, we plug into negative 3. Okay, so negative 3 goes in for y. 2 goes in for x. So this is like negative 8. If I add the 8 over, what's b going to be?
5.
B is 5. Okay, and they say y equals negative 4x plus 5. And then they say write it in function notation where y is f of x. So you just say f of x equals negative 4x plus 5. That's it. They're just being silly about it.
That's kind of dumb.
Carson?
Mr. Coffee.
No, he did not come in here.
My foot.
They're not back. I don't think they're back.
Yeah, yeah, seniors are not back yet. Or they, yeah,
Or they're.
I don't think they're back yet.
They're not.
Yeah.
How long is
Okay.
this court case?
Happy with that? That wasn't too hard, right?
They're supposed to be back by 1. But I don't
Okay.
know what time.
All right,
Okay.
next, computing average rate of change. Average rate of change. Another name for average rate of change is
Derivative. I don't know.
derivative, actually, but slope.
After,
Slope. And slope is y2 minus y1 over x2 minus x1.
Can we
Derivative.
use
What we know
No.
about derivatives?
You don't have an equation here.
Make one.
Sure.
Hey, remember what she said? Jalen said that next semester we'll be all ready to go for this stuff.
Yeah, you will. You'll be fine.
Calc,
You'll be
so.
just fine. All right, blah, blah, blah. Oh, a line drawn through at least 2 points on a curve is called a secant line. Hey. Hey. At least 2 points on a curve. So this guy right here. Now, if I draw him through only 1 point, what's that called? My tangent. A tangent line. Okay, so 2 points on a curve is called a secant line. I can find the slope of that secant line by doing the slope between the 2
my
points.
classes are mushing
Okay.
together, and I'm forgetting
You
which
betcha.
information is
You
where.
betcha.
Yeah.
Example 6. They want us to
Look, I
find
remember this
just,
Calc or Trig.
yeah. They want us to find the
Or
average
A
rate of
physics.
change. Shh. They want us to find the average rate of change, which is slope. And they want us to find it from 0 to 1. So if we do part A, I'm going to put A down here. They're saying 0 comma something to 1 comma something, right? If our x1 is 0 and our x2 is 1, we're going 0 something to 1 something, okay? 0 is at what?
0 is 0.
0. 1 is at
0.06.
0.06. And then I want to find the average rate of change, which is slope. So y2, 0.06 minus 0 over 1 minus 0, which is 0.06 over 1, which is 0.06. So that is the average rate of change or the slope, 0.06. And that is actually 6% if you want to write it out, because this is concentration, so 6%. So it's going on average from 0 hours to 1 hour, it's going up 6% per hour. Does that make sense? This is my average rate of change. So from this point to this point, it's going up 6% per hour, right? Now, it doesn't continue that way. If it would continue to go up 6% per hour, my second hour would be up there, and my third hour would be up there, right? So it's not continuing to go up at the same rate of 6% per hour, because it's going to level off a little bit. But that's what that means, okay? Part B. We're going from 1 hour to 2 hours. So 1 comma something, 2 comma something. 1 is at 0.06, 2 is at 0.09. Okay, so I have 0.09 minus 0.06 divided by 2 minus 1. So 0.03 divided by 1, or 0.03 or 3%. So it drops from increasing at a rate of 6% per hour to now only increasing at a rate of 3% per hour, right? It's going up like not quite as steep now, okay? Oh, interpret the results from part A and part B. This is part C. So, from
Hey, Michael.
hour 1 to hour 2, it is increasing. How so?
By 3%.
It what? From hour from hour 0 to hour 1, it's increasing
6%.
faster. 6% in parentheses. It's increasing faster than from hour 1 to hour 2,
3%.
which is 3%. Okay, so it's increasing at a steeper pace or a faster rate from 0 to 1 hour than it is from 1 to 2 hour. Does that make sense?
Yes, ma'am.
Clear as mud?
Yes, ma'am.
Okay, holy cow. Okay, there's C. Go for it. Write that
I wanna
down.
be done.
Write that down.
You want to try Michael and figure it
Wait, so
Yep.
that's just basically like a conclusion to what we did.
Yes.
Yeah, that's just our conclusion. Yep.
Hang on, there's a word that I want.
Okay, ready? Done? Back page? Kind of move on? All right, here we go. Average rate of change again, except they're giving us not a graph, but they're giving us an equation now. My algebra kids are doing this exact thing right now. Hey, look at that.
Does she look scary? Can you see her?
Okay. Given the function defined by this equation, determine the average rate of change from -2 to 0. That means -2 comma something and 0 comma something. We're going from -2 to 0. And all I have to do is plug them in to find the y coordinate and then do the slope. So if I plug -2 in, -2 squared is 4 minus 1 is 3, 0 squared is,
Yeah.
yep, -1. And then I do what?
What two max?
The slope, because I'm doing average rate of change. So -1 minus 3 over 0 minus -2. -4 over 2, which is -2. So on average, it's going down
Why did
2.
we add 2? Oh, never mind. I know.
It's going down 2 units per unit that it goes over, right?
Using the two negatives in there and the shoes.
Wait, can we use power?
What?
No power rules.
No,
No.
not for this one.
2x. This would be 2x.
Yeah.
Yeah.
2x.
And you would only need 1 point instead of 2 points.
Plug in
Because your average rate of change won't always be the slope of your tangent.
Power rule can be really, really dumb.
So
We don't know
anyway,
what you're talking about.
all right, moving on. Good.
Well, it was confusing for us.
All right, now we're switching over to inequalities. Inequalities. What's an inequality?
Doesn't equal.
Inequality means not equal. So less than, greater than, less than or equal to, greater than or equal to. We're gonna graph these.
The first one is literally.
Okay. The first one, we gotta solve for x. Get x by itself. I'm gonna subtract this x over here. And can I add the 3 at the same time?
Yes.
Okay, so I get x equals
2.
2. Just 2. Oh, x equals 2. And this one is an equal sign, so this one we're not doing an inequality. How do you graph x equals 2?
Lines.
Straight line at 2, up and down. X equals 2. We solve for him, we graph the line.
It always
That is all.
confuses me. The up,
Yeah.
down,
Is
and
there
up.
Okay.
still
Same.
the quarter to 9?
Okay? Now this one is the same thing again. We're going to subtract the x, add the 3, so x is less than 2. How do I do x is less than 2?
Oh.
You have to shade it.
We do a dotted line. Why is he a dotted line, by the way?
Because he is not.
He's not equal to, and then we shade to the left, because that's everything less than 2, right? That's the little bit of difference.
I like those things.
Yeah, these ones aren't bad.
I
Okay,
remember those.
this is the same one again, except this is going to be x is greater than 2, okay?
The opposite.
We still have a dotted line, though. And he is going to be
To the other side.
to the other side, to the right side. We like these.
Yes.
Equal to is a solid line. Yep, so if it's greater than or equal to a solid line, but you still shade.
I remember this. This was like 2 years ago.
Yeah.
You used to like have multiple and find like which one would overlap.
Yeah, that's probably what we're going to do maybe next.
Algebra?
Yeah,
It is easy. It was easy.
okay? Good?
I like that stuff. Give us all those, Tony.
What?
Give us all those.
That's easy.
Okay.
What?
Someone else does.
Okay.
What happened?
All right.
I don't know. What happened?
Here's A.
I heard that.
Yeah.
Yeah. All I heard is that she said something on.
The rest, like the rest of them. What did Moose say?
Kinda. You just laughed? Yeah. You didn't yell. You would have yelled at me.
That's probably one of the. It's probably one of the like the. That's probably just like very little to what it's doing.
I was gonna
If that would have been me, you
All right.
would have yelled at me.
A, I'm going to solve him down below. And we have to solve for X. And that's all we have to do.
distribute
They left the hot
the
plate
two.
on.
Let's distribute the 2. 6X. Then what?
Yeah, me and Reese did that.
Mr. Muth compared making fun of me.
We're almost done.
Ball yesterday.
Sorry.
6X. Then what?
Minus 2x.
Minus 2X. Minus 4. Minus 5 equals 0. Then what?
Combine the like terms.
Okay, these two.
6x.
4x.
2x.
Minus 9 equals 0.
Plus 9.
Plus a 9.
4x minus 9 equals 0.
Divide by 4.
X equals 9 fourths.
4x
9/4
9
or
divided by 4 divided by 4.
2.25. Sure. That.
2.25.
Okay. I don't know. B says use the graph to find the solution. I'm just going to find the solution. This one would be, okay, this one would be, it's the same thing again, right? This one would be X is less than or equal to 2.25.
9 fourths.
Oh, 2.25?
Yeah.
Okay. And that's B. And then
that's
C
the sign.
is X is greater than or equal to 2.25. Now, they graphed, let's talk about this for just a second. Up here, we had these graphs, and we graphed a solid line like this, and then we shaded left and right, whatever, okay? You can, if there's only one variable, you can graph them on a number line instead, right? Because we don't have like really a second axis, right? We don't need the y-axis on there. We could just graph him with an X. And so he looks like this. Whoop. And we have 2.25, and we have a solid dot, and he is going to the left, which is the same thing as saying 2.25, a solid line, and everything shaded to the left. Those two things mean the same thing. It's just that this one, you are only looking at one number line. Here, you're looking at the y-axis as well. Make sense? But they're saying the same thing, okay? C is the same thing, but just an open circle, but to, or no, excuse me, closed circle to the right. Right? Closed circle to the right, okay? But keep in mind, you can graph him on a coordinate plane, or you can graph him on a number line. It's fine. Either one. Questions about that? I feel like this is like a really straight, easy for like whatever section. Okay? There you go. That's all I have.
Yay,